Good afternoon, everybody. Welcome back after the lunch session. So my session is titled Code for Cloud. Amil actually, he put a chat last month and asked, whether I can do a session on Code for Cloud. And then, I was wondering, okay, what am I going to talk about? And then, why this particular topic? So then, I just started thinking about it. Out of the 20 years plus years I've been in WSO2, for more than 15, I've been in engineering and architecture and writing code, right? And then the last 5 years where, I started running operations, heading SRE. And it's sort of a totally different ball game. That's where, I started blaming my old self, the coder, Azeez. Now, what the hell was I doing? I was thinking this is not my problem, right? So when you run code that is written by engineers in production, you start to see real problems. It started, some of the code might have been my code, coming back to, bite me. So what happened was we started seeing lots of issues. When we started our cloud offerings, our public cloud offerings. I'm not sure whether they can delete this from the record, right? So when we started running Choreo and Asgardio and so on, we actually started seeing the problems that, probably our customers have been seeing for a while, but we started seeing real challenges, right? So you will have run into scalability issues, you will run into security issues, then how to manage sensitive information, right? So you have to think about disaster recovery, multi-regional deployments. So when I was on the other side of the fence, right? When I was an engineer, the typical my attitude was, okay, it's not my problem, right? So we are creating products, we are building products, we host it out there. Somebody else is going to take it and run it, right? So they will figure out the rest of the stuff. So if they need, firewalls, if they have to scale it, it's their problem. I have tested it on our machine, we put it on a VM, maybe we run some load tests, figures look good, we release it. So after, starting running into this problem, this sort of became a recurring thing, because when you go into cloud, now you have to continuously release stuff. You have to continuously update. It's not like you're going to do a release every 6 months, right? So you're continuously releasing several times, maybe even several times a day. So how do you decide that something that you're going to run in production on the cloud is actually production ready? So what I did was, there were recurring problems. Whenever you release a new feature, you might end up breaking something else in production, right? You cause pods to crash, right? Things that were working fine in production, you update, and then things crash, and then you have to revert, or sometimes it's not even easy to get to the underlying problem. So I actually created a checklist, right? I created a checklist for developers. So typically, right, when you are a developer and you are given a requirement, you think about, implementing that requirement, right? So you are asked to, implement this particular feature. You implement the feature, which is called the functional requirement, and then you are happy, right? As a developer, you test it typically on your machine, or you run it, host it somewhere. You run a few tests, you run your JMeter test, and you're happy, right? So as a developer, myself, I wasn't that worried about non-functional requirements, because it was, typically we used to think of it as some other person's problem. So first of all, okay, just to cover some of the basics, I will, in the rest of the slides, I will touch upon some basic stuff, because I think since, this is the WSO2 audience, we have a mixed audience, it's good to, remind ourselves of some of the basic fundamentals. What are functional requirements and non-functional requirements? So we learned this in software engineering, right? In university, you learn this. functional versus non-functional requirements. So functional requirements are the actual core features, right? The business logic. The non-functional requirements are related to how the system is going to behave, right? So scalability, how the system is going to scale under different loads. Are you going to scale it vertically? Are you going to scale it horizontally? How are you going to secure the system, right? And then how much it is going to cost. So that's a very important thing. So one of the targets that we have to achieve this year is reduce our public or cloud cost by 50%, right? Very aggressive target. But as a developer, when you, let's say you are given a feature, you don't really worry about cost, right? So I would be, my main focus would be about coming up with an architecture to solve the problem. So the architecture might be a very elegant architecture. So you can't come up with an ideal architecture. There is no such thing as an ideal architecture, right? So an architecture is actually a compromise. So you given certain factors, you come up with a particular solutions architecture, right? Typically what we see is, you might go with the industry best practices, you layer it, and then you put several layers of security. All of that, actually, if it's going to result in the cost exponentially increasing, and you don't see a return on investment on that particular feature, it's going to cost you, right? At a certain point, you might have to, throw away that work. You might have to decommission it because it's costing you too much to actually run, and you can't. At the end of the day, somebody has to pay for it, right? So customers might not be willing to pay the price of that. So you have to take cost as a factor when you come up with an architecture. And that has to get reflected in your architecture, design, and code, right? So those are important aspects. Okay, the other point is operability. So you have written a feature. How easy it is to operate? Operate in the sense, when an operational team, how can they run that? How can they, see insights? If a particular feature you implemented is causing some issues, it's causing memory spikes, it is failing, how can a person who is running that system proactively, get to know that, something is failing, right, before actually it catastrophically fails? So that's, one aspect of operability. So we'll talk about this the rest of the slides. So just to give an example about a feature and how we come up with the functional versus non-functional side of things. So the functional requirement is, so the requirement is you have to have an API to deploy Core applications so that you can remotely call it and deploy your applications, right? So functional requirements are very straightforward. So you have to deploy an application to a specific environment, and then you should be able to promote it from dev to stage into prod and so on. And then depending on your PRs and so on, your build pipelines could get triggered and it will deploy it. And once it is deployed, the deployment status is returned to the caller, right? But then you have this set of non-functional requirements. So the API, so let's say you have an API, so you have to think about, is this going to be a synchronous API or an asynchronous API, right? So then, how long it is going to take, what kind of, latency constraints you have, and then how can you support thousands of, concurrent deployments across different organizations, and then you have to think about the security aspects, how do you isolate, these deployments from different organizations or different users without, getting in the way, right? So maintaining that isolation and access, right? And then even, say, once you have deployed it, your system has to, remain active or running even if your build systems fail, right? So your build system is just a supporting part. So so again, you can't have systems that never fail, right? So you have to always engineer for failure and expect failure. So one of the typical mistakes we developers make is, we assume that certain things are, given, certain things are not going to fail, right? So you have to plan for those failures. So let's take a system or like Choreo. You deploy your application, it's running perfectly, or the customers or the users of that application are, using it. But due to some reason, you have a failure in your deployment pipeline. So you can't deploy new versions, but the existing versions continue to run. So it's a partial failure, but it's not catastrophic, right? The system continues to run. So you basically isolate those aspects. So the pipeline aspect failing, so this is called compartmentalization, and then we have in microservices, we have this bulkhead pattern and things like that where you compartmentalize failures. So certain sections can fail, but the rest of the system continues to run. So then again, the fifth point there, deployment failures should be observable. So the thing is like if you have to build in observability into your system, so that might not be a requirement. So Amila or somebody spoke about logs, right, during this session. So one of the ways in which you can detect that a system is starting to fail is having a high rate of error logs. So that is actually sort of the final resort. That's not a good way of monitoring the health of a system, right? You have to have other probes, right? So in order to see whether a system is healthy, you should have the probes. So like think about vehicles. You have the diagnostic systems, right? OBD1, OBD2, and so on. So those are built in. So that's not required, right? A vehicle can perfectly run without an OBD system. You don't need error codes. It will perfectly run. But why do you have that? So in case of failures, you can now scan and pinpoint where it is failing. So the vehicle manufacturers built that in, which is actually not a primary requirement, not a functional requirement, right? It's a non-functional requirement. So similarly, when it comes to software, we have to build in those probes. So typically we know that when we can't see why it is failing in production, one of the things we do is we give patches with logs. Right? So you give a patch where you are logging, which is actually printing out, info logs or something like that, so that you can track the path and figure out where it's failing, because you can't debug in production, right? You can't put a debug pointer and then, pinpoint it. And certain issues will occur only under production conditions. It will not occur in low environments, right? So making it observable, auditable, and then, being able to, integrate it with alerting systems is another functional requirement. And then, of course, the cost budgets here. So every aspect of it, you have to think about the cost budget. So how many of you have seen the cloud, that checklist, the feature development checklist? So I think that's sort of a mandatory thing, because before you, at the point of actually designing a feature, you have to think about these aspects. Like, especially cost is something that people miss, right? So again, a little bit of theory, which is also related to this topic. So the fallacies of distributed computing are amplified when it comes to, cloud deployments. So typically, this was actually introduced, I think, more than 30, 40 years ago, and then it was like originally 7, and now new stuff have been added. So you can see the last 3 points are actually added very recently. Versioning is simple, compensating updates always work, observability is optional, right? So when we write code, right, the network is reliable. So I won't go into everything. I think most of you must be familiar with this, right? So the network is reliable. So when you make that assumption, automatically, you think, so when we write some code, let's say from one method or one function, we are calling another function. You generally don't think that that's going to fail, right? Function to function call within a particular process is not going to fail. So you don't put in these guardrails. In case it fails, what am I going to do? Maybe you have an exception handling mechanism or something like that. Apart from that, you don't have retries and stuff like that. It generally works. Another typical mistake people would make is they assume, okay, network calls also work like that. So that this is actually, this is amplified when it comes to libraries that you use. So you might be using a connector library or some third-party library, maybe a JDBC library. You use that and you are making a call, right? So it looks like a in-process call, but underlying what's happening is there's a network call going on, right? So you don't assume that to fail. So we have seen this, like typically you forget about that, you don't think that it's going to fail, but that fails. So like when I talk to the SRE team, I always say, okay, I don't say if failure happens, when failures happen, right? Because failures are always going to happen, right? Bad things are going to happen. So that's our mentality. But when I was a developer, we have this very optimistic view, right? So things you think, okay, this is not going to fail, not in a million years, but then like it will fail, right? So it does fail. So you have to, so like the best example is like this Azure front door failure, and we were evaluating, as an alternative, we were evaluating Cloudflare because Cloudflare hasn't failed for quite a long time. And we were like, when we were in the last phase of evaluation, Cloudflare failed twice, right? So everything in a distributed system is going to fail. So you have to think about the redundancy, you have to think about, replicating systems and so on, but again, cost also becomes a factor, right? So the more the nines you have, right, you can add more and more nines, right? I'm talking about availability, right? So you can have 4 nines, 5 nines, but every 9 you add, your cost increases exponentially. So you have to keep that in mind, right? Yeah. So traditional software feature development thinking, yeah, I covered some of these things. Typically, built to be downloaded and installed on known environments. So we test on particular environments, and then we think that, okay, it's working here, so it's going to work everywhere, right? We generalize it. We assume that infrastructure, once you provision the infrastructure, that's stable, right? So we used to do something called a capacity plan, where you actually, you guess, or you guesstimate, you talk to your customers and you ask, what kind of load are you expecting, what kind of peak, right? And then when you have that figures, again, in most cases, the customers also don't know that, right? So they guess and give you a value. And then you over provision, and then you acquire or you procure hardware for that, and then you keep that running, right? So the world has changed from that. And then you are optimistic about failures. You don't expect failures to happen. And then scaling, again, you can manually, if you feel that, okay, the load is going up, or during seasons, the load is going to increase, you can manually, provision extra capacity. Stateful by default, security is mainly the perimeter security, right? So you put firewalls, web application firewalls, and so on, right? So you assume that if you put the perimeter security, you are safe. So in your code, you don't have to worry too much about security, because somebody else outside the castle has taken care of that, so that intruders can't get in, right? So as developers, we sort of think that we are in a safe zone because the security guards outside the border are going to take care of security for us, so we don't have to worry about it. So traditional software thinking, right? Operational complexity is not the software team's problem, it's the operation team's problem. And then because the capacity and so your scaling is again manual and so on, you think that know what it is going to cost, right? So the bottom line is, if the software runs correctly, you think, okay, my job is done. But how does it break in the cloud, right? So the cloud, again, is a very sort of dynamic, toxic environment, right? So containers are coming and going, and things are failing constantly, and automatically, there are automatic recoveries, right? And the systems scale dynamically, right? So you can't assume that you're going to have a single replica or 2 replicas. You don't know, right? So if somebody can configure the system to scale, right? So the scale parameters could mean that now your system runs with like 25 replicas. But whereas, you have actually tested only with 3 replicas maximum. So with like when you have 25 replicas, you can't assume that, okay, just because it worked properly with 2 or 3 replicas, it will work perfectly fine with 25 replicas. So let's imagine that your application is written in such a way that everything is pointing to a single database and that layer doesn't scale. Now you just scale up your pod layer and you expect, okay, under load, I have we have put the horizontal pod autoscaler, so this should just scale and it should work. But then your database becomes a bottleneck, and then all the pods fail, right? Right. So we have these are not actually made up stories. These are nightmares that we have experienced. Again, yeah. So again, you can see how the fallacies of distributed computing are coming into play here, right? The network is unreliable, latency, again, is not predictable. So you can't have manual operations, everything has to be automated. Failures are normal and frequent. And then you can't tie state to instances, right? So you have to, so I have seen code where there was like a static variable, state maintained in static variables, right? So, and released. So what happens is, okay, like static variables, you test it with, one request, things work finally, right? Things work fine, right? But the moment you now send concurrent requests, and the moment, it is replicated, everything falls apart, right? So you have to pay attention to those things, right? So even, so as much as possible, like you have to make it stateless. So another thing that some people do is, you make it stateful, but then you have this session binding, right? Session-based routing and stuff like that. Again, that used to be, it's like a workaround, but that's not actually a good architectural practice. So you should try to make your application stateless. Then again, you can't assume that the perimeter security is going to take care of everything. So you have to have multiple layers of security, right? So perimeter security is again mandatory, but you have to assume that that boundary will be breached. Once a breach, they come into your code, you should be able to compartmentalize. You basically like reduce the attack surface. So once they, let's say, you have a deployment and a particular tenant has been compromised, so you have to make sure that the attacker can't break out of that and now attack other tenants, right? So you have to, that stuff has to come into the architecture and the code, right? And then there is this thing called cloud washing. So typically, sometimes, you take stuff that has been just running on VMs and then you put it into containers and you say, okay, now we are cloud native, we are running on the cloud, so cloud washing is just, it doesn't work. So what it means to, what this means for how we write code, you have to design assuming failures are normal and not exceptional, and then, you have to think about NFRs as first-class inputs, right? Not just the core requirement. NFRs have to be a primary concern when you are, developing a system, right? So in the cloud, code is incomplete without its operational behavior. So you have to think about the operational behavior. So non-functional requirements are first-class requirements. We talked about it. So that the NFRs will have a heavy influence on the architecture. So if you consider just the core requirements, you might come up with one architecture, but if you consider the NFRs, that might, totally change the architecture. You have to think of it from a different point of view, right? So again, let's say cost, right? So your ideal architecture is not going to be economically feasible. So you have to change it, right? So again, the ownership. So NFRs is not anybody else's problem. It is now the architects and the engineers' problem, right? So if something matters in production, it's a requirement. If it's functional or not, if it's going to impact the production system, it's a requirement. So main areas, so I'm just the rest of the presentation, I have a few slides on NFRs to consider. So this is actually part of that checklist we created as well. Cost, security, resilience, data management, resource efficiency, operations here. Cost governance, we spoke a lot about it. So cost is directly actually shaped by the architectural decisions and design decisions, right? So, so this can quickly add up. So it's like this, right? Again, like Sanjeeva mentioned, there is no sort of end design or end goal. It's all about iterations, right? So, so you don't have to come up with an ideal architecture to go into production, right? So sometimes this ideal architecture might be very, costly. So then, you can't actually get your customers because they are not willing to pay that. You can't cover your cost. Your losses are very high. So initially, you might have to go with a compromised, or, you have to adjust the architecture with, according to these constraints. And then, you slowly evolve it into whatever the ideal architecture you need to get it into, right? So maybe like you don't, like, you want to have an architecture where you can scale into 1,000 replicas, but you're not having any customers who are going to, immediately, buy into that, right? So you come up with an architecture which will, work with 5 replicas, right? So that's good enough for you to, go to market. So every architectural decision has a price tag, right? Security, we spoke about it. I think we can skip that. We, to emphasize, like in the cloud, security is not a perimeter, it's the behavior, right? So you have to think about it at every layer. Failures are expected, but not exceptional, right? So if you're talking to, if you're talking over the network, you have to be aware of that. When you're writing code where you're using connectors, you're using libraries, right? You have to be aware of that. You have to build in resiliency, and then, you have to have an idea of, the idempotency of the party that you're calling, right? If I retry, what kind of error will it cause, right? If there is an error, can I compensate for that, right? Can I roll back what was done, right? So those things all translate back into the code. So resilience is not about avoiding failure, because you can't avoid failure. Failures are going to happen. You anticipate it, and you have to survive it, right? Data management. Again, like lots of assumptions are made by engineers when it comes to data, right? So one of the things, okay, we have a new sort of arm in SRE that we started, where, Chatura is looking into database optimization as well as the financial and cost optimization, so like the FinOps side of things. So one of the things that we have with some of our products is at the database access level, or the way we utilize databases is inefficient, right? Maybe the queries are inefficient and so on. So it was not a problem, at when you're having a deployment per customer, where customer has a little bit of data. But when you have a multi-tenanted cloud scale deployment, the cost quickly shoots up. So like sometimes, it's inefficient. The queries become extremely slow when the data grows, right? So due to, not having the proper indexes, or, sometimes we found tables where there are no primary keys, right? So you can index, and then, those tables, those queries which touch those tables are becoming bottlenecks, right? So then what we do is we throw more resources at it. We have to buy more reserved instances for the database. So again, adding to the cost. So again, the other thing is like the compliance and the data residency. So we have to think about at cloud scale running in different regions, right? So then how are we going to do the disaster recovery, right? Can we have a multi-regional redundancy? Or, what are the laws governing that? What are the compliance sides, or what's the compliance side of things? So these are aspects that we have to think about. And then utilizing resources efficiently, right? So one of the things people assume is like when you're on the cloud, you can allocate as much resources as possible. It's not a problem, not a concern. If you're running it on a data center, yeah, you're physically constrained, but there's infinite capacity available in the cloud, which is not true, right? We have seen this with some of our cloud deployments where we have sort of hit the regional capacity, right? So then when you hit that, you can't actually go and allocate or provision more VMs. You have to request, because we might hit the physical capacity of the data centers or where the systems are run, right? So you have to request, and then provisioning that can take quite a bit of time, right? So so even if you are running on cloud, you have to think about efficiently running or utilizing resources, right? So that's extremely important. So there is this very popular statement: premature optimization is the root of all evil. How many of you have heard that? Premature optimization is the root of all evil. Who said it? Who said it was said by a popular computer scientist. So people, think, okay, premature optimization is the root of all evil, so we will not optimize, we will write something that runs, even if it's crappy, it runs, it's okay. And then now if you put this in the cloud, right, that's going to be the root of all evil, right? So you have to think about optimization, right? I'm not saying that you have to get paranoid about this, but it's something that we can't ignore. Right? It can't be an afterthought. You can't say, okay, like I will optimize this later. Because some of these decisions, can't be reversed. Because sometimes, in order to optimize, you have to make some major changes. Let's say you have to make a database schema change. That's extremely difficult when it comes to a production system. You have to migrate customers. You might have to take a downtime, right? So then you have to now inform all the customers, okay, that we are going to do this. Even with a blue-green deployment, sometimes there is this risk of failure. So then for critical customers, you have to inform them in advance. So when you do that, actually customers panic. They really don't want any notification like that. So even if we give the assurance that, okay, this is just a precautionary warning, it will not go down, they get uncomfortable with it, right? So some of the decisions, it's not easy to reverse once you have, put it into your code. Scalability, you have to design your system for scaling. My time is up, so I will go through this, right? So like I said, sometimes it might work with 2 replicas, but it fails with more replicas, right? So you can't just, and when it comes to certain problems, you can't just think that by scaling your business logic layer or adding more replicas is going to solve the problem. Your bottlenecks might be somewhere else. So you have to plan for it. Operations, this is the most important, or the area that I am mostly interested in. So think about how your features could be monitored, right? To build in those probes, and then again run books. Right, so there's something called incidents, right? So we know what incidents are. So what happens is when something fails in a production system, the operations team gets alerted, right? And then that results in an incident. So one of the first steps that we do in our standard operating procedure is we try to follow a run book to resolve that incident. So then, like this, let's say this deployment API feature is something that you developed and that is failing. Right, that API is failing, and the SRE team gets an alert. So at that point, SRE team will see, whether there is a run book. So what can I do to resolve this? Maybe the run book says like, you can't do anything fancy, right? At that point, so at 2 a.m. in the morning, you get an alert saying this API is down. You have to do some basic stuff, right? It has to be properly, documented, stepwise. So you log in, and then like maybe you have to increase the replica count, or you have to roll back to the previous working version, something like that. So as engineers or developers, you have to think about, how your feature could fail, right, in a cloud deployment. And then if it fails, what are the steps that the operational person has to take? right? So again, we can collaborate. The operations team and the developers can collaborate to jointly develop that. So final slide, key takeaways. Start thinking about NFRs at design time. Treat cloud-native checklist as the thinking framework. So that's the checklist that I spoke about. So you may probably, for like different products, you might have different checklists, but you need to have that so that you don't miss it, right? So as humans, we tend to forget things, but once you have this, when you send the PR itself, you have to ensure that, okay, all these items are addressed. And then, yeah, finally, optimize your system for boring, predictable production systems, right? Yeah, I think we can end the session. If you have any questions, we can discuss, yeah.